Welcome to section 3.5. In this section we're going to talk about atomic mass some more, but we're going to relate that to something called isotopes. Isotopes by definition are atoms of the same element that have different mass numbers. Remember, I told you that the number of protons cannot change, but it can have different numbers of neutrons, and so that's how we change the mass number, by having different numbers of neutrons. So if for example, if they're carbon, okay, and carbon's mass number is 12 and its atomic number is 6, that means it has 6 neutrons. But what if it had more neutrons? Then it would have a different mass number. It would still have the same number of protons, so it would still be carbon, but it could be heavier, so it could have more neutrons. So if we look at how we write these atomic symbols, if we have oxygen, the number is 8, okay, its mass is 16, so we write oxygen with the 8 below and the 16 above to the left. That tells me I've got 8 protons, 8 neutrons, and 8 electrons. Where did that come from? Well, I know that's protons and electrons, and I know that this number minus that number gives me neutrons. So if you look at phosphorus 31, okay, you have 15 protons, you have 15 electrons, but 31 minus 15 is what? 16, so I have 16 neutrons. In zinc 65, I have 30 protons. Where's that coming from? The atomic number, okay, 30 electrons, and then to find the number of neutrons, it's the mass minus the number. 65 minus 30 is 35. So that's how I get these numbers. And when I write them, I write the mass number on top and the atomic number on the bottom. Notice, this is magnesium. Magnesium, like many of these elements, can exist at different masses, okay? And they naturally occur this way. Some are more stable than others, all right? And so I could have magnesium 24, magnesium 25, magnesium 26. These are all isotopes of magnesium. What's the difference? They all have how many protons? 12. Okay? They all have 12 protons because their number is 12. What's the difference though? 24 minus 12 is 12 neutrons. 25 minus 12 is what? 13 neutrons. 26 minus 12 is what? 14 neutrons. So the only difference between these isotopes of magnesium is what? The number of neutrons. The number of protons do not change. If it didn't have 12 protons, it would no longer be magnesium. And so here's what I just told you. Now, when you look at the periodic table, you will see a mass of around 24 on that table, okay? And so what they do is they look at the different isotopes that can occur, and then they look at how much of each type there is, and they come up with something called a weighted average. A weighted average. And that's taking into account how much of each one of these occurs, because the average depends on, you know, you're going to have more of this, so that has to count more. So you have carbon that occurs naturally in 3 isotopes: carbon 12, carbon 13, carbon 14. How many protons are in carbon-12? How many protons are in it? What is its number? Its number is what? 6. Yeah? All right. How many protons would be in carbon-13? 6. It has to have the same number of protons or it's no longer carbon. All right. How many electrons would carbon have? If it's neutral, it's got to have the same number of electrons as it does protons, right? And so the only difference is going to be this one has 6 neutrons because 12 minus 6 is 6. This one has 7 neutrons. This one has 8 neutrons. So again, the only difference between these isotopes is what? The number of neutrons. All right, so now let's write these symbols. And remember, we have the number, both numbers are going to be to the left, okay? And it's going to, first you're going to have to figure out what element it is by the number of protons. So I'm going to have you put this on pause, and I want you to look and see if you can figure out which one has 8 protons. Well, it's going to be whatever is atomic number 8. Yes? All right, but you're going to have to write these symbols on there after you find. All right, so put it on pause and see if you can do this. All right, outstanding. So element number 8 is oxygen, and 8 protons plus 8 neutrons gives you 16 as a mass. Okay, 17 is chlorine. 17 plus 20 gives you 37 for the mass. Number 47 is silver, and 47 plus 60 gives you 107 for the mass. Very good. Which of these pairs are isotopes of the same element? Okay, which of these pairs are the same isotopes of the same element? What's the main thing that you have to have in order for them to be the same element? I hope you're right. What is it? Well, the thing that does not change, right? They have to have the same atomic number. So those are isotopes of the same element. And the second question to this is, in which of the pairs do both atoms have 8 neutrons? So in order to find out neutrons, what we have to do is we have to say 15 minus 8 equals 7. 15 minus 7 equals 8. So they don't both have 8 neutrons. 12 minus 6 is 6. 14 minus 6 equals 8. Okay, that didn't work either. These pairs, though, 15 minus 7 is 8, and 16 minus 8 is 8, and so these guys would both have 8 neutrons, right? Very good. So I mentioned this earlier, that the atomic mass that we report is a weighted average of all the naturally occurring isotopes of that element. And so when we put that number on the periodic table, that is a weighted average. Okay? And we can look at that number and kind of tell which one it's closer to, and pretty much tell you what is the most abundant, like what do we have the most of. So to calculate the atomic mass, we're going to use the experimental percent abundance, multiply the percent abundance by the atomic mass, and then sum those up for each isotope. What the heck is she talking about now? All right. To calculate the atomic mass of chlorine, we're going to use experimental data, okay? So we know that 75%, 75.76% of chlorine we see as 34.97 AMUs. 24.24% of it is 36.97. If I multiply 34.97 times the percent, I get 26.49 AMU. If I multiply 36.97 by the percent abundance, which is 24.24, I get 8.962. I add those two together, and I get 35.45 AMU as the average atomic mass of the isotopes. So there's only 2 for chlorine. These are some others. They're just examples of different ones and how they have weighted those. All right, so here, first of all, let's see if we can eyeball this. Lithium has 2 naturally occurring isotopes, lithium-6 and lithium-7. When you look at the periodic table, the mass you see is 6.941 AMUs. Okay? What they're asking you to do is to predict which one is the most prevalent. Which do you have more of? How would you do that? Well, if it could be a mass of 6 or a mass of 7, and the weighted average is 6.9, which one is that closer to? 6 or 7? Well, it's a lot closer to 7 than it is to 6. So probably lithium-7 is going to be the most prevalent or the most abundant. All right, now here's how we do this one. Gallium is an element that we use in lasers for compact discs. In a sample of gallium, there is 60.10% of gallium-69, which has an atomic mass of 68.926, and 39.90% of gallium-71 that has an atomic mass of 70.925. What is the atomic mass of gallium? So what it's basically asking us is to do a weighted average of this, okay? And so you set it up just like before. All right, you have the atomic mass, which is 68.926, times the percent, which is 60.10 out of 100. Okay, and then you're going to get a number for that. And then the other one is 70.925 times 39.90 out of 100. And then you're going to get a number for that. And then you're going to take this number plus this number, and that's going to give you the atomic mass of gallium. All right, and if you do that math, let's see what you get. Well, according to the book, you should get 69.72 AMUs, which is what you will see if you look on a periodic table of gallium. So that's how they do it. They just take the weighted average. The difference between a regular average and a weighted average is you take into account the percent prevalence or abundance. And that's the end of section 3.5. You're probably glad because we had to do math, but that's okay. That was the end of isotopes and atomic mass. And so I hope that you will stick with me and join me for section 3.5.